We are ready always. Hi guys, let's start. I'm very happy to see you on our online webinar. We have absolutely special guest, Julien Simon. I tried to
Hello.
say it with French pronunciation.
Yeah, you managed it well. Thank you.
Julien is principal developer advocate AI and machine learning at Amazon. I heard Julien's speech, I think 1 or 2 years ago here in Kiev. Now we have, of course, only online format. And today we will have online meetup simplifying dataset preparation with Amazon SageMaker processing. We will have, I will tell you a little bit about our company, Data Science EA. After that, we will have a very interesting speech from Julien. And after that, we will have Q&A session. We have chat here in Zoom. You can use this chat. If you don't mind, please write now in our chat what is your position: data scientist, data analyst, maybe data engineer, maybe manager. From which city are you? From which country? It is very interesting. And maybe what is your aim? What is your goal for today meetup? Maybe you have questions. Please write. We will be very happy to read it. I will tell you a little bit about our company. We are Data Science UA. We are building data science community here in Ukraine from 2016. Now we have few tracks in our company. We have track education. We organize Data Science EA conference. Data Science EA conference, it is our big international brand. We organized already 8 conferences. Some of them were offline here in Kiev. One of them was online. We will have our 9th Data Science EA conference in November 20th. I invite you. Julien will be our speaker in this conference too. We organize courses, meetups, workshops about data science, AI analytics. Before quarantine, of course, everything was offline in Kiev. Now, of course, because of quarantine, everything is online. That's why we're extremely happy to invite participants from all the world, from Ukraine, Europe, USA, Canada, from all countries. We have a very efficient recruiting team, and we help to find best projects for data scientists around the world. We can close not only data science positions, all IT positions, like front end, back end, architect, C-level, absolutely everything. But of course, our main focus are data science and AI positions. Please meet our recruiting team: Nastya, Alena, Alexandra, Bogdan, Oksana, Sofia. You can write them if you're interested in our positions. They will tell you more about projects, about requirements, about everything. Don't hesitate to find them and to write your questions. We have consultant track. We are helping to companies with business analytics, data collection, machine learning, advanced analytics, data mining, business intelligence. If you have data, we will help you. We know what you can do with your data. Nika Tamayafor, she's head of consultant data science EA. She knows everything about data and how to make best predictions and insight from your data. Please write to me or to Nika. We will help you to find best way of using AI in your company. We have education and mentorship programs about data visualization and data science for managers. Now, of course, we can do it online and we can custom course based on your needs. If you are working in fintech, we can do data science cases for fintech, for e-commerce, customly for your company. Please write us. And few months ago, Data Science EA launched new track. We opened AI R&D center here in Kyiv for our American company. We hired absolutely efficient and extremely uh, cool team of computer vision, machine learning, server-side engineers, and we are doing very difficult solution for industrial manufacture and safety. We can open AI R&D centers here in Ukraine. It is our main focus. We know all data scientists here in Ukraine and in Europe. And if you have cool project, we can find to help you best team. It is a promo of our conference, which will be held in November 20th. Uh, there are a few of our speakers. We will have 24 hours conference. Will be held three tracks: business track, technical track, and workshop track. Julien will be in our conference. He will be speaker with very interesting topic: end-to-end natural language processing with Amazon SageMaker. Thank you for coming, Julien. Please follow us in social networks. We have page in Facebook, we have Telegram chat, we have Instagram page, and we have YouTube channel. We have a lot of videos from our previous offline conferences, Data Science here. You can check it in YouTube. Please write me about everything about data science, which developers you need. I will be very happy to help you. And now word to you, Julien. Thank you one more time for coming. It is pleasure for us to see you in our conference. I see some words in chat. Yuri, CEO Banking Kyiv. And somebody asked about sound. Do you hear me, guys? Do you see everything is in chat, guys?
Yes, yes.
Yep,
Yes.
works for me.
Oh, Julian, word to you. Thank you
Okay.
one more time.
All right, let's get started. Okay, so good evening, everybody, because there is a small time difference. And so my name is Julian. I'm tech evangelist working for AWS. I've been with AWS for about 5 years now, and have had the pleasure to come to Ukraine quite a few times. I know you have a really, really great tech community over there in Kiev and Lviv. So unfortunately, the world is crazy right now, and we have to rely on conferences and online conferencing to be able to interact. But I really, really hope next year I can come and visit you again in person and get some good Ukrainian food, which I really like. And yeah, I have to apologize for the football game last night. I'm quite sure if your team was the normal team, it would have been quite different. But anyway, so good luck to Shevchenko to rebuild the Ukrainian team. Lots of work there. But now we're going to talk about machine learning. So in this session, I'm going to focus on probably the most time-consuming step in the machine learning workflow. And of course, I mean data preparation. As we know, all of us working on machine learning, it takes quite a lot of steps to build a machine learning model and deploy it in production. Spend all your time writing crazy machine learning algos, training models, the cool stuff. But in practice, you're going to spend lots of time collecting, preparing, cleaning data, right? That early stage of the process. And then, of course, you're going to try to find an algorithm that fits your data set, and you need to build and manage training infrastructure in order to train and tune your models and try to keep track and manage all the hundreds or maybe thousands of jobs that you run inside a project. And then the real difficulty starts, bringing the model in production, managing prediction quality, monitoring performance, scaling prediction infrastructure, etc., etc. So you have to go through all those steps. And a few years ago, as machine learning became a growing priority for customers, they asked us to solve that problem for them, right? Make it easier to build machine learning workflows from experimentation to production. And so we listened to quite a few different customers because everybody's doing machine learning a little bit differently. And we came up with Amazon SageMaker. Okay, so SageMaker is really our flagship service for machine learning, and it lets you go from experimentation to production using a single service with many different capabilities, but under the same umbrella, so to speak, and the same APIs. So the purpose is really to help you go from left to right, as quickly as possible. Go from data collection, data preparation, all the way to scalable production as quickly as possible. So over time, we added capabilities in SageMaker to help you with every step of the way. But today, I'm going to focus exclusively on the data preparation step. Okay, in my talk at the conference, I will actually show you the full process, and it will be a different data set in case you're wondering. I'm a very lazy person, but I'm not going to speak about the same thing again. So make sure, if you're interested, make sure to attend my presentation at the conference, where we'll use a different data set and we'll go all the way from data cleaning, processing, all the way to deployment. So for today, we're just focusing on that early step. So what are the options, right? I'm sure all of you have existing tools to run data cleaning and feature engineering and basically all the batch jobs that you need to run inside your project, right? So maybe some of you use Spark, maybe you use Hadoop, maybe you use your own custom code. There are many different ways to do this, and on AWS, obviously you could use big data tools to do this, right? You could use maybe Amazon EMR to run Hadoop or Spark in a managed way. You could run your code on EC2 instances. You could use all our database services to perform transformations on your data. We have an ETL service called Glue, AWS Glue, that lets you run ETL jobs. So there are plenty of different ways. Okay, so we thought, hey, let's pick one capability and integrate it in SageMaker in the easiest way possible. Because when you're focusing on machine learning, you want to spend 99% of your time, maybe 100% of your time on machine learning and not on anything else. Okay, so this is a service that we named, or a capability, I should say. SageMaker is the service. We named it SageMaker Processing. So SageMaker Processing is fully integrated with SageMaker. It has super simple APIs, as you will see. And what it lets you do is run batch jobs on your data. So probably data cleaning, again, feature engineering, but you could also use it for model evaluation if you want to run test sets or cross validation on trained models. You can absolutely do that. So in a nutshell, all the batch activity that takes place before training and after training, pretty much. Okay, it's fully managed, so you never worry about infrastructure at all. You never have to provision, configure, etc. Any instance, it's all done for you, as you will see. So that's very cool, because if you have no love for infrastructure, and again, if you're working on machine learning, that's what you should focus on. You can completely ignore infrastructure here. You can bring your own code, of course, because data processing is going to be data set specific. So you can bring your own scripts, and as you will see, it's very easy to even integrate existing scripts in SageMaker processing. You don't have to rewrite anything. You can just adapt it very easily, as I will show you. All activity in SageMaker is based on containers, so training, deployment, and also processing. So we provide you with a scikit-learn built-in container, so you can write your scikit-learn code and just run it. And as of a week ago, you can also run PySpark on processing. If you so that could potentially replace Spark jobs that are running somewhere else. So that's pretty cool. And you can also bring your own container if you'd like. So if you need to run, I don't know, C++ feature engineering, why not? You can do that, build a container. And of course, all that stuff is running on AWS. So everything you know about the cloud, everything you like about the cloud, I hope, like built-in security, built-in compliance, on-demand infrastructure, pay-as-you-go, etc., still applies. Okay, so what you need to do here is just bring your processing code, scikit-learn or Spark, adapt it to basically know where to read the data set and where to write the process data set, and write a few lines of Python code to get everything going, as we will see. And that's it, right? And you can forget about managing, scaling, paying for clusters or any kind of infrastructure that you use traditionally to do this. Okay, so enough slides. I want to do two demos for you. We're going to start with a first demo based on Spark. And then I'll show you another demo based on scikit-learn, and I'll throw in an extra SageMaker capability called SageMaker Experiments that helps you manage all your jobs. Okay, so we'll see about that. But let's get started with Spark first. Okay, so let me switch to my browser. Okay. All right, so what you see here is the SageMaker console. So if you already work with AWS, you're familiar with the AWS console. If not, well, the console is just the web application that you can use to work with all AWS services, right? And yes, we have more every day. It's getting quite busy here. So inside the SageMaker console, you can, we'll see SageMaker processing jobs. We'll see that in a minute. And one of the cool features in SageMaker is the availability of built-in development environments. Okay, so we have the initial development environment, which is called notebook instances. And notebook instances are basically managed EC2 instances pre-installed with Jupyter and all the libraries that you need. So you create one in just a minute, open it, and then you jump straight into a Jupyter notebook, right? And you work with it just like you would work with Jupyter on your machine. So I'm going to use this one first for the first demo. And in the second demo, I'll use a more recent development environment called SageMaker Studio, which is an IDE running in the browser. Okay, but for now, let's look at notebook instances. So I've created one already in the interest of time. But again, it just takes a few minutes. And here we have a notebook where we're going to process a data set using Spark and SageMaker processing. Okay, so there's a little bit to read. The first important bit is, of course, you need the SageMaker SDK. And just so you know, we released a major revision of that SDK in early August, I think. So SageMaker SDK 2.x, okay? And so you could see in older notebooks, you could see 1.x. There are a few differences, but not so many. It's mostly renaming, and there are very few breaking changes. So anyway, we need that SageMaker SDK, and I will show you the APIs to get everything going. Okay. So first of all, we need to get some data, right? That's the point. So we're going to download some data from, it's actually hosted in Amazon S3 or storage service. And it's a well-known data set. It's the abalone data set, which describes the abalone shellfish, right? And the name of the game, if you train with this, is to predict the age of that shellfish based on physical properties like weight and size, etc. Here we're not going to train, we're just going to clean that data and well, process it more than clean anyway. Okay, so I'm grabbing this data set, it's in CSV format. Okay, so just downloading it, and this is what it looks like. So here I have a category, right, which is really the label. So M is male, F is female, and I is infant, right? So it's an infant shellfish, why not? So we have 3 categories, and then those 1, 2, 3, 4, 5, 6, 8, those 7 no, I'm sorry. This is no, the label is here. Okay, sorry, the label is here. I got confused. So it's the age. We need to predict the age. Okay, so that's the age of the shellfish, and here we have so the gender, so to speak, and the so that's probably 7 if I can count the 7 features for for each data sample. Okay, so it's a simple CSV file. So obviously there's not a lot of processing to do here. It's just a simple example. But anyway, let's apply Spark to this. Okay, so here we have a PySpark script. So even if you're not super familiar with Spark, you can I'm sure you can understand this. So what are we going to do here? Well, we have a categorical variable, right? That first column is a category, male, female, infant, and all the other ones are numerical features. Okay, so what we're going to do is basically we're going to one-hot encode that categorical feature. We're going to index strings and then put everything together as a vector. Okay, we could probably normalize data also, although you could say, the range of that data is pretty consistent. So I guess normalization would not add much. But anyway, so that's what we're doing. And we're using, as you can see, vanilla PySpark APIs, right? Nothing extraordinary. So we're receiving some command line arguments, which are really the only things you need to add to your code. Okay, so basically that's where you're going to tell your script, this is where the data is hosted, and this is where to write the process data set. And as you can guess, it all takes place in S3, right? So put your data in S3, load it from there, process it, and then write the data back to S3. Okay, and as you can see, the rest again is completely standard code. Okay, so we define a schema, read that CSV file from the location received by the script, right, and apply the schema to it so that we have column names. And then we apply those PySpark transformations, string indexing, one-hot encoding, building the vector, etc. Okay, then we create the actual pipeline by listing the different steps. Okay, then we apply the pipeline to the data set. Okay, we train it, we transform the data set with the model, We split for validation and training, 80-20. And then we just convert the data frame back to a CSV file, and we save that CSV file in S3. Okay, so very typical of what you would do even if you were working on your own machine, right? Load the data, process it, save it back. The only difference here is you're loading from S3 and you're saving in S3. Okay, so this is the code we're going to write. Okay. All right, and then, of course, we need to apply this code to the data set. So now we're using that PySpark processor object from the SageMaker SDK. Okay, we're creating a unique timestamp for that job. Okay, we upload the data, the CSV file, right? So that's the one, the initial one, right? We just downloaded. The unprocessed one, okay? We upload it to whatever location we defined in S3, okay? So now it's waiting to be processed. And we define the processing job like that, okay? So give it a name, pick a Spark version, and decide how much infrastructure we want to use. Okay, so remember when I said SageMaker it really makes infrastructure transparent. Well, this is a good example. The only thing we say here is, hey, I want to run this code using 2 instances of ml.m5.xlarge type. Okay, and if you're not familiar with AWS, those instance types, they look a little bit strange, but ML means it's a SageMaker instance. M5 is just, M is the family name. The M family is a general purpose instance type that works well for typical machine learning jobs. M5 is just the 5th generation. And xlarge means how much memory and processing power you have. So as you can imagine, we have a wide selection of CPU instances and GPU instances. And of course, you can find all the specs online. Okay, but so M5 large and X large are good choices and very cost-effective choices for, I would say, normal jobs. Okay, so that's all we do here, right? And then finally, we run the job, passing the location of the code. Okay, so that's the Spark code you just saw. Passing arguments to the script. Where's the data? Where do you write the process data? Where do you write your logs? And that's about it. Okay. And so when you call that run API, it's going to fire up those 2 MLM5 xlarge instances running Spark. Okay. So distributed training is available out of the box, right? If you needed 8, you would just say 8 and you would not think twice about it. So everything runs on its own. It runs for a couple of minutes. And at the output location that you specified here, you're going to find your data, right? So we can use here I'm using the command line to copy from the output location to my local machine, and I'm displaying the top 5 rows. Okay, and we can see this data has been processed according to the script. Okay, and it could be, it obviously here it's a small data set, it's a very simple transformation, but if you had terabytes of data in S3, and if you were running this on I don't know, 16 instances, why not? You would reuse exactly the same code. You would just say, okay, give me 16 instances, and if you need GPU instances, you would just ask for GPU instances, etc., etc. That's the good thing about the SageMaker SDK, is that it's high level, right? And you don't need to change it when you need to scale. Or when you need to work with bigger data set. The logic is always the same. Input data in S3, output data and models when you train in S3, and manage infrastructure in between, right? And distributed training is automatically set up, etc., etc. Okay. Yeah, we can, if we want, we can also view the Spark UI. We have the job history here. No, it's shut down. Okay, I shut it down. Okay, so it's here. But if it was running, we could see the Spark. We could see the Spark app there, right? So here's the example. So you have the link to this. The example continues with more advanced things like adding dependencies or running. If you have a packaged app, if you have a jar file, you can obviously run it as well. It's exactly the same logic, right? So you can check it out. But in the interest of time, I'm not going to repeat the steps. They are really, really the same. Okay. So this is an example with Spark. And here, as you saw, I used a notebook instance. So now let's look at a second example. And this time I'm going to use Amazon SageMaker Studio, which is a web-based IDE for machine learning. It's available in a couple of US regions, and it's available in Europe as well. So I'm using the Ireland region for this. So you can find it here in the console. You need to set up a user. We just use the simple wizard. It takes a few minutes. It's super simple. And then you can open Studio and you jump. You should see something like this when you get into it. And it's based on Jupyter Lab. So if you're familiar with Jupyter Lab, you'll be very familiar with SageMaker Studio. Okay. So of course we can create notebooks. We can create. We can just work as we normally work. So I've got my code ready here. So let's take a look at this. So this time we're going to use scikit-learn, and we're going to process it. To use it to process a marketing data set. Okay. So again, the first step. Let me close this thing here. Maybe zoom in a bit. Of course, the first step is to download data, right? And we can see that data, and this is what it looks like. So it has about 41,000 lines, 20 features, and one label. And so the features are customer features, you would say, right? And it's a lot of categories like job and marital status and education and a few more things. And all the way to the right, we have this Y column, which tells me yes or no, did this customer accept a marketing offer? Okay, so it's a binary classification problem for this one. And we can solve this using all kinds of algos, of course. But here again, we're going to focus on processing the data, right? So once again, it starts with uploading the data to S3, okay? And then this time we're using the sklearn processor object, training or processing, I should say, on M5 XLarge again, and calling run, passing our script, and passing some parameters to the script. Where is the data? Where do you save the process data? And there's a command line argument for the train test split ratio. Okay, so as you can see, again, exactly the same logic. Put your data in S3, configure the processing job with a simple object from the SDK, pass your code, pass input, output locations, and any arguments, and then it runs on its own. Okay, so you can learn this thing in 15 minutes, right? Now let's look at the processing script. So of course it reads the command line argument. It loads the data from the location, the input location. It's going to remove any line with missing values. It's going to remove any duplicates. And then it does a few things like counting the yes samples and the no samples and printing out the ratio. And as it turns out, this is a rather imbalanced data set, as we can see, right? We have 8 times more no's than we have yeses, which makes sense. More people say no to marketing offers than they say yes. And then we're cleaning a few things. For example, there's a column called no previous contact that, sorry, there's a column called P days that tells me how many days ago did I last talk with that customer. And there's a silly placeholder value, which is 999, which obviously does not mean 999 days. It means we never talked to that customer. So that's a problem, right, in machine learning data sets, all those placeholder values, because they create a false sense of scale for that column. So, it would lead the model to think, 999 is really a value, and it kind of shifts the distribution of values to the right in this case, which is not right. So instead, we create a new column called no previous contact, which is valued 1 or 0, depending on whether we talk to that person or not. We also group students, retired people, and unemployed people as not working, because the reason would be, these people don't have a potentially a solid income, so they're probably not as likely to spend money than the other ones. So to say, well, those three things, those three jobs have something in common, we add that column. You could think of other IDs, right? These are just simple things. And then we split for training and validation using the split ratio parameter. And this time we build a simple scikit-learn pipeline using the standard scaler to scale all numerical values, and one autoencoder to encode all the categorical variables, right? So we pre-process this thing, and then basically we save the training set and the validation set to the appropriate locations, right? So once again, I'm sure if you use scikit-learn for data processing today, and I'm sure a lot of you do, it's a very popular and it's a very good choice for that. You can very easily adapt your code, right? The only thing you need to do is basically read the input and output locations and apply that, right? Okay, so we run this job, and if we look at the S3 location, well, we can see the train data and the test data, exactly just like in the previous example. Okay, so that's nice. Now, one thing you're likely to do is you're going to do this many times, right? Because you have many data sets. Maybe you want to process them in different ways. You want to apply different transformations. You want, in this case, maybe we want to try different split ratios. My point is you're going to do this a lot, right? And the problem is, of course, if you do something a lot, it becomes a little difficult to manage. If you do this hundreds of times, thousands of times, you end up having to track all those jobs. So this is where SageMaker experiments come into the picture. So it's another SageMaker capability, and it's super simple to understand. So the purpose of SageMaker experiments is to help you track all jobs involved in a machine learning project. Okay, so you do this using the SM experiments SDK. So the first step is to create an experiment. So an experiment is a project. Okay, so it's going to group a bunch of related trials. Okay, a bunch of related ideas that you want to try to solve the same problem. Okay, so first we create that experiment, and it really means just give it a name, right? And then just to give you a very simple example, we could say, all right, let's try and run 3 processing jobs using different split ratios. Okay, so I'm iterating over those 3 values. And for each of those values, I'm obviously going to run a job, right? And I can see my parameter being passed here on the same data set. Okay, but I want to track those 3 jobs, and I want to group them in that same experiment so that I can find them easily later on. So each trial is going to be unique. So I create a name using a unique timestamp. and I attach each trial to the experiment that I created above. Okay, and then I just run my processing job exactly the same, except I have an extra parameter here, passing the name of the trial, right? So that's all it takes. And so of course we're going to see 3 jobs now. Okay, 1, 2, 3. Okay. And well, I'm using SageMaker Studio here. So Studio is not just vanilla Jupyter Lab. It has also some integrations with all those SageMaker capabilities. And one of them is experiments. So let me show you this. Okay, so in that experiment window, let me reload this thing. Okay, that's the last one that I created just before the session. I can see this, this experiment, right, which is the one running here. So if I click on this, I see there's a processing job in there. Okay, and or is that the right one? No, that's the one. So there are 3 processing jobs in there, okay, corresponding to the 3 jobs that we see here. Okay, and I can see my my pre-processing job here. Okay, so I can see all the parameters. I can see the input and output locations. You know, basically all the metadata associated with this. Okay, and so that's nice because it helps you figure out which is which. But of course, if you have really a lot of them, what you want to do is be able to explore them programmatically, right? And so part of the SageMaker experiments is about that. So you can just simply create this experiment analytics object from the experiment that you just run, and you can load all the data inside of a data frame. Okay, and then of course you can start querying and filtering. You can actually pass search queries inside of that experiment analytics object, or you can use native pandas to go and do it, which I find slightly easier anyway, and go and figure out how compare those trials and maybe compare trials across experiments, etc. So here it's just the beginning of the trip, right? Because we're only pre-processing, but let's say now we would train with those different data sets. We could do the same. We could run training jobs and attach them to that experiment. And so we would build also traceability, which is very, very important for machine learning. We would be able to easily figure out that this model comes from this training job, and this training job used a data set that was processed by this script at this time, etc. So if you just have a couple of jobs, of course you can do that in an Excel sheet. But if you have hundreds or thousands of or tens of thousands of different jobs, it becomes messy very, very quickly. And here this makes it very, very easy to log all that information. You can log additional parameters. You can add a tracker to your trials. You could, for example, I could add the split ratio. That probably would be a good idea, right? Log the split ratio, and it would show up as an extra column for all those jobs, right? So again, super simple, nothing fancy, but something simple and super useful that helps you figure out where those data sets come from. Okay, and SageMaker Studio provides some visual cues on what's going on, right? And very quickly, yeah, you're gonna have a ton of those, right? So you want to be, yeah. See, so this is a more elaborate example with AutoML jobs and data processing jobs. So you can see all the different jobs attached to the trial, and the logic behind each one of those. So experiments is a good one. It's a very easy one to learn as well. Okay, well, that's what I wanted to show you. Maybe just as a conclusion, we focused on this today, right? We spoke about SageMaker processing, which is the data processing and batch processing capability inside of SageMaker, but there are plenty more things inside of SageMaker. And again, I'll mention some of them in my conference talk, and I'll share some resources on the next slide. But there's much more to machine learning and AI on AWS. We have a collection of AI services, which are basically API services based on pre-trained models, models trained by AWS. So you just pass your data and get predictions. For example, you can do image and video analysis, you can do speech to text, text to speech, translation, and so on, right? Not going to go through all of them, but if you, you should take a look at those. Maybe they're good enough to save you from actually building a model yourself. And of course, at the bottom, we have all the infrastructure and framework tools for customers who want to build, manage their own infrastructure for machine learning. So all the EC2 instances, CPU, GPU, FPGA, Inferentia, which is a custom chip that we built to accelerate and optimize the cost of predictions. And of course, we have packaged versions of all those cool libraries that we love so much. And we optimize them to make sure they run as fast as possible on AWS. Okay, so there's quite a lot to learn, as you can see. So where do you go next? So if you're curious about all those services, you can go to ml.aws to learn about all the stack. If you're specifically interested in SageMaker, this is the SageMaker page with customer references and features and all the high-level information. This is the AWS blog, and it has quite a lot of posts on SageMaker. So if you want to stay in touch and know about all the latest announcements, this is probably the place to go. The Python SDK that I mentioned, the collection of sample notebooks that we have. We have hundreds of notebooks showing you how to use SageMaker and all its capabilities in pretty much every configuration. This is my YouTube channel, which has quite a lot of videos, my Medium blog. And if you're looking for more events, we're actually starting this Friday for 6 weeks, every Friday, where we have this event called SageMaker Fridays, where we're going deep on real life use cases for machine learning and how to solve them with SageMaker. So there's if you're deep into ML, this is the one for you, right? For the first episode will be LSTMs and time series and pretty crazy stuff. So you should like that. And of course we have reInvent, our technical conference coming. And this year, unfortunately, it's going to be online. It's not going to be in real life. But the good thing is it's free, right? So please join. You can learn a lot about AWS and SageMaker. And last but not least, I published a few weeks ago a book on SageMaker. It's the first of its kind. It's a 500-page overview of everything there is to know about SageMaker. All the capabilities you saw on the slide are presented there. I have about 62 original notebooks in there, so lots of code. And if you're interested, you can order it from all kinds of places, of course, but there's a discount for the paper edition. Unfortunately, it's only on Amazon US, but it's a very deep discount, so it might be worth checking out. It could definitely offset the shipping costs. And if you want the ebook, you can get it from the Packet website, and make sure to use the 20 SageMaker discount code, and you're going to get 20% off. This is only valid until November 11th, so you have about 1 month to go. And after that, you'll have to pay full price, I'm afraid. Okay, so don't wait. All right, well, I'm done. I want to thank you very much. So it's a pleasure to talk to you guys again. I wish we were in the same room and we could chat about machine learning for a few more hours, but hopefully in 2021, right? Obviously, I will send my slides to Alexandra, and she can distribute them, and I'm sure you will have the recording as well, so you're not going to miss anything. And if you have questions in the future, please get in touch. Twitter, LinkedIn, I'm easy to find, and I'm always happy to answer your questions. So don't be shy and ask me. Okay. Thanks again. Thank you very much.
Julien, thank you